Hi, this is Noelle Tillison, and in this video we are going to look at strategies for multiplying multi-digit numbers. We are going to focus specifically on 3-digit by 1-digit. In order to be successful in the area of multi-digit multiplication, we must have a conceptual understanding of area, a conceptual understanding of the distributive property of multiplication over addition, fluency of all single-digit multiplication facts, and a conceptual understanding of place value, specifically times 10 concepts or multiplying by multiples of 10. We are going to start off by looking at the problem 125 times 6. When I am looking at a strategy to multiply a number that has 3 digits by 1 digit, I can rely on area models and the distributive property of multiplication over addition. The first thing I'm going to do is to decompose 125 into hundreds, tens, and ones. So I now have the expression 100 plus 20 plus 5 times 6. I'm then going to distribute the 6 and multiply 100 times 6 plus 20 times 6 plus 5 times 6. I can illustrate this through the area model. I drew my area model and I know that the smaller dimension is 6, so I'm going to label the correct side of my rectangle. The length of this side is 125, but I'm going to break apart by place value and partition or decompose my rectangle into 3 smaller area rectangles. I find the area of each rectangle by multiplying. I know that 1 times 6 equals 6, and this is 100 times bigger, so I know that 100 times 6 is 600. 20 times 6 is 2 tens times 6, which is 12 tens, or 120, and 5 times 6 is 30. I can add these areas together to get my product, which is 750. We can also look at the same problem written out in another way without the area model. Can you see the connection between the two strategies? Let's look at these two strategies again with another problem. This time we are multiplying 368 times 7. It is a good idea to get an estimate before you solve the problem so you can see if your answer is reasonable. So I put my estimate in a thought bubble like this. I know if I round 368 to the nearest hundred, it will round to 400, and 4 times 7 equals 28. I'm making it 100 times bigger, so 400 times 7 equals 2800. I can also round down to 300 and get the estimate of 300 times 7. I know that 3 times 7 is 21. This is 100 times bigger, so 300 times 7 equals 2100. I know that my product should be between 2100 and 2800. Let's look at the area model to solve this problem. I can decompose 368 by place value. I labeled the width of 7 and decomposed the rectangle into 3 smaller rectangles to represent the areas of 300 times 7, 60 times 7, and 8 times 7. I now multiply 300 times 7, which is 2100, which I know from my estimate. I multiplied 60 times 7, which is 6 tens times 7, which is 42 tens, or 420, and I multiplied 8 times 7, which is 56. I add my areas together, and I have 2100 plus 420 plus 56, which is 2576. Let's look at that written out without the area model. 368 decomposed into place value. The 7 is distributed to each place. The products are added together. Compare the area model to the partial product strategy. The open area model helps to build conceptual understanding of the distributive property and place value that helps students make sense of multi-digit multiplication. Students should be provided with opportunities to build connections between models and algorithms in order to build procedural fluency with understanding. Now I would like for you to try this with the following problem. I would like for you to show it through the area model and without the area model as well. Don't forget to estimate. Press pause while you work. When you are ready, press play. For my estimate, I chose to round down to 600 times 4. I know 6 times 4 is 24, and this problem is 100 times bigger, so 600 times 4 is 2400. I know that this estimate will be lower than my actual product because I rounded down. Okay, let's start with the area model. I label my shortest side width 4 and decompose my rectangle into areas that represent 600 times 4, 20 times 4, and 4 times 4. I multiplied 600 times 4 and the product is 2400, just like my estimate. 20 times 4 is 2 tens times 4, which is 8 tens or 80, and 4 times 4 is 16. I added up my products and the final product is 2,496. This answer is reasonable because my estimate was 2,400. Let's look at this strategy without the area model. This is a partial product strategy because you are finding part of the product and adding them together to get the answer. When you compare it to the area model, you can see the 600 times 4, the 20 times 4, and the 4 times 4 with the products as represented in the area model. In this video, we looked at using area models and the distributive property of multiplication over addition as a strategy for multiplying 3-digit by 1-digit.